Hello, my name is Christopher Garcia, and today I'm gonna be teaching you stoichiometry 101. In stoichiometry, we're basically trying to find how much grams or moles there is in a certain molecule with by using another mole through the equation. So basically, it's a ratio between how much grams or moles find. So, for example, here we have the question: how many grams of N2 is there? But there is 18.1 grams of NH3 and 21.0 grams of CuO. So to find that, we would need to observe 18.1 grams of NH3, 2 grams of N2, and 21.0 grams of CuO to N2 as well. And so we will use the formula so in the first one is 18.1 grams of NH3. To get the answer, you would actually have to get rid of the grams of NH3 by multiplying by the molar mass how much mass there is in 1 mole of NH3. So to get this number, you would have to add up the molar mass of nitrogen and 3 hydrogens, because that's how much there is in the molecule, and you would get 17.0. And so these two would cancel out, this one and this one, and you would get and then you would multiply that answer with 1 mole of N2 over 2 moles of NH3, which, because that's how much moles there are in the equation for each one of the things. And that would cancel, NH3s would cancel out with that, and you would get 1 mole of N2. So now you're gone, you don't have any more NH3s. You're in the N2s now. You have the moles of N2s. So then you would multiply how much moles of N2 there is, and you would cancel that out, and you'll multiply that by the molar mass of N2, which is 28.02 grams, which you would get the same way you would got the molar mass for NH3. And that would all cancel out, and you would be left with the answer of 14.9 grams of N2. Pretty neat, huh? And and so you would basically do the same thing, but with 21.0 grams of CuO, and you would get 2.47 grams of N2. So you got two answers, but you don't know which one the right answer is. Well, the right answer is the one with least, because you would eventually run out of one of these two by the time the equation ends. So you have a lot of CuO and a lot of NH3, but one of those are going to run out first, and it would be CuO, because it got 2.47, which is a smaller number, and 14.9, which means CuO would be the limiting reactant, because it limits the reaction. It's pretty self-explanatory. And which would mean NH3 would be the excess, because there's an excess amount of it. So you would also have to find how much excess there is in total. What you would do is you basically work backwards. So you would get 2.47, which was the limiting reactant, the amount of grams there is in the limiting reactant, right? And you would work backwards. So you would find 28.02 grams of N2, which is the molar mass of N2, and you would basically do the same thing backwards and work backwards to get 3.0 grams of NH3. And then from there, you would actually subtract 18.1 grams of NH3 from 3.0 grams of NH3. In order to find, the limiting reactant itself. And you would get 15.1 grams of NH3, and that would be the excess amount. I'm sorry, I said limiting reactant before, I meant excess. I'm sorry, my bad. And from there, you would have your answer, right? But you're not done, because you gotta find the percent yield, which is the percent between what you actually got in your experiment. So whenever you go to experiment, you would get an answer, which, you know, you probably won't get the exact same answer as you got in the equation because of error, which you can get from many different results. You didn't measure something right, or, you know, we're not perfect, so, you know, you're probably gonna screw up, but hey, whatever. And so you would get the actual yield, what you actually got, over the theoretical yield, what you would theoretically would have gotten if you wouldn't have messed up during the thing. And you multiply that by 100, and you would get the percent yield. So here you get, so let's say, theoretically speaking, because this is not part of the lab, this is just an equation, you got 2.00 as your actual yield. That's what you got. So what you would do is you would put 2.00 over 2.47 grams of nitrogen, because that's how much nitrogen you ended up getting, and you multiply that by 100, and then you would get 81.0%. And yeah, that's stoichiometry in a nutshell. So um, overall, I think I did a pretty good job, and I hope you learned something. And yeah, Christopher Garcia is signing out.